Okay, last year in Math 1, you guys learned how to prove figures were congruent. Today we're learning how to prove triangles are similar. Okay, last year you learned how to prove triangles are congruent through side, side, side. You had angle, side, angle, 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 side, all that good stuff. Do you kind of sound familiar?
Yeah.
Okay, we're gonna do that same thing with similarities now. So let's review our definition of similar figures. Are all sides are proportional and all angles are congruent. So what does that mean? So you can clearly see that angle A is congruent to angle at R. Okay, this is the angle mark, angle, just so you know, that's the angle sign. Angle B is congruent to angle S. Those are congruency marks when I put them on the angle. And angle C is a right angle, sorry. And angle T is a right angle, so those are also congruent. So angle T is congruent to angle C. Does that make sense? So all my angles, my corresponding angles are congruent. Now let's see if our sides are proportional. So make sure you're getting corresponding sides. So side AB is 5. Corresponding to that is side RS over 2.5. Okay, then we have BC is 3 and ST is 1.5. Then we have AC. AC is 4. Why does it keep doing this? Is 4 over 2. Does that make sense? Now we have to see if those sides all reduce to the same proportion, because right now they don't look the same, but will they all reduce to the same thing? 5 and 2.5, they both be divided by, they can go into each other. 2.5 can go into 5 2 times. 1.5 can go into 3 2 times. And 2 can go into 4 2 times. So they all have the same proportion ratio, right? 2 over 1. So their scale factor would be 2 over 1. Makes sense. So those two figures are similar. So we would say that triangle A, B, C is similar. Remember that little squiggly line is similar to, then we look for, in the smaller triangle, A corresponds to what in the smaller triangle? R. And B corresponds to S. And C corresponds to T. It's very important that you put them in order. Okay? Since all the angles, the corresponding angles are congruent and the corresponding sides are proportional, those two triangles are similar. Now here, they want to ask you, are the figures similar? So we need to check that. We start by looking at the angles. Well, angle A is congruent to angle D. That works. And angle C is congruent to angle F. But is B and E congruent? Okay, well, let's see. Does anyone remember how many degrees are in a triangle? Yes. 180. Very good. We're going to write that down. The sum of the interior angles of a triangle equal 180 degrees. So in this case, we'd say 40 degrees plus 60 degrees plus the measure of angle E should equal 180. So this is how I can find the measure of angle E. So 40 plus 60 is 100. I'm going to subtract 100. So the measure of angle E equals 180. Let's try it again. Let's subtract better. What's 180 minus 100? Very good. It's 80. So this is an 80-degree angle. Would that work on this side as well? Right, it'd be the same thing. 40 plus 60 minus 180 would make this 80 as well, right? Okay, so we have all the angles congruent, right? So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Now let's see if the sides are proportional. So we have 32 over 40. Does that equal 24 over 30? It should be equal to 36 over 45. Any questions over that? Let's reduce. Okay, this can both be divided by 8. 32 divided by 8 is 4. 40 divided by 8 is 5. We do the same thing here. 24 and 30, how can that be reduced? By 6. So that's going to be 4 over 5 as well. The last one, what can it be divided by? Very good, 9. Bless you.
Thank you.
36 divided by 9 is 4 over 5. Woo, they all match. Okay, so let's do our similarity statement. Okay, Jenny, can you name that first triangle for me? What? Okay, triangle ABC is similar. Stephen, can you name the other triangle that corresponds to that? To what? D, E, F. Again, make sure C goes with F, E goes with B, and D goes with A. Any questions over that? Okay. Now we have various ways to prove triangles are similar. We talked about transformations in the last 2 sections. If you want to review that, I've given you guys some links that you can go look at. Just to review, okay? Okay, but if we transform figures, we can prove they're similar through rotations, and then we have to have a dilation. Okay, we can now prove without transformations through angle-angle. If two angles are congruent, then the triangles will be similar. Which is kind of what we talked about here. We had two of the angles, we didn't have the third angle. But eventually it's going to add to 180 anyway, so you'd figure that out. Okay, and from there we can conclude that the sides would also be proportional. Okay, so we just need two angles to prove the triangles are similar. So we have that here. Let's do a similarity statement. Triangle. Caleb, name one of the triangles for me? C, B, A. Okay. So triangle CBA is similar to triangle. R has to go with C, right? Okay. Then B goes with S and A goes with Q. Any questions over that? Okay. We could also do this through side, side, side. Okay, if you have all three sides and you can show that they are proportional, then you can say the triangles are similar. So here we're going to say 9. 9 is the biggest side. Oh, it's millimeters. So what's the biggest side with the other triangle? 6. So 9 goes with 6. 7.5 is the middle one. And it goes with 5. And then 6 is the smallest, goes with 4. Okay, 9 and 6 can both be divided by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. Okay, 7.5 is 5 times 1.5, 7.5. Okay, so this would be, to simplify this, you'd have 75 over 50. Okay, 75 and 50 can both be divided by 25. 25 can go into 75 3 over 2 times. And sorry, 50 can go into 25 2 times. And then 6 and 4 can both be divided by 2. So good. The sides all have the same ratio of 3 over 2. Any questions over that? Okay. So those would be similar. The last one is side angle side similarity. So if you have two sides and their included angle, the included angle is congruent and the two sides are proportional, then you can prove the triangle is similar. Okay, so we have 12 over 6. Is that congruent to 10? Sorry, is that 10 over 5? Are they the same? They both can reduce to 2 over 1. So we could say those two triangles are similar. Okay. Blake, name one of the triangles for me. QRS is similar to, okay, what goes with Q? B, triangle B, C, A, good. Are we catching on to this?
Yes.
No. You just said the letters correctly. Okay, let's do the next one together. Okay. Okay, determine if the two triangles are similar. Explain. So tell me why. Is it angle, angle, side, 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 or side, angle, side? Okay, if they are similar, write a similarity statement like we just did. Okay, so currently I have one angle congruent, right? I have 33 and 33. So angle C is congruent to angle N. How many do I need to prove they are similar? 2. So I need to find one of the missing angles, right? I'm going to use the bigger triangle. Okay, I have to find angle B and see if that goes along with angle M. Okay, so I know the sum of the interior angles of a triangle is 180 degrees. So I'm going to say that 79 plus 33 plus the measure of angle B is equal to 180. So 79 plus 33 plus the measure of angle B should equal 180. I'm going to combine those two and get 112 equals 180. So far, so good? Then I just subtract 112. Oopsie. And I have the measure of angle B equals 68 degrees. So do I have another angle that's congruent now? Right? Angle B is going to be congruent to angle M. So now I have two angles that are congruent. Can I prove those are similar? Yes. Because one of our rules is if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay? So that's how I can prove this. Okay, so I'm going to say triangle. Name the triangle for me. A, B, C is similar to triangle Okay, Brandon, what goes along with angle A in this triangle? Which angle goes with angle A? L, very good. So triangle L. Then what goes with B in this triangle? M. And then N. Okay, so that's our similarity statement, and explain by angle, angle, similarity. Yes.
Does it matter if you put like just in general, if you put an LN, or does it matter?
Okay, so it does matter. You have to link it with this one. So you name one of them, it doesn't matter how you name the first one. You can put it in any order. But then you have to have it with the corresponding side. So you have to have A, what goes with angle A has to be the first one over here. So angle A is 79 degrees. Angle L would have to be 79 degrees too then. So L has to come first. Then B is 68 degrees. So you have to have the 68 degree, which is M. It really matters what order you put the second one in. Any questions over that? Okay. This one we need to go over. I have two angles congruent. 61 and 61. Is another angle that I can also, yes. S. Okay, this angle is congruent to this angle. These vertical angles are congruent. When you have two lines that intersect that form that X shape, the opposite angles are congruent. So QSR is congruent to UST. Okay? And you're going to write that down. Angle QSR is congruent to angle UST because vertical angles are congruent. And that's a theorem that you should have learned in Math 1. And I think even in Math 8, you guys talked about this.
Math 8?
Yes. In 8th grade math?
Oh, there's something like
Sorry, 8th grade math. They called it Math 8. Yeah. Shh. Okay, so now I can prove my triangles are congruent. So triangle, Lizette, name one of the triangles for me. TSU is similar to triangle. Okay, what goes with T? Class, what goes with T? Which one goes with T? R, right? They're both 61. R has to go first. Then what goes with S is S, and U goes Q. And we say they are congruent by angle, sorry, not congruent. They are similar by angle similarity. Guys, the talking needs to write down, okay? Okay, next one. What is MN? Okay. We can prove that these are similar because they have two sides that are proportional to each other. Because they both are 75 over 1. This is also 75, and this is also 1, because those are congruency marks, right? So this is congruent to this, and this is congruent to this. We have 75 over 1 and 75 over 1. And then we have their included angle congruent. And angle JLK is congruent to angle MLN because vertical angles are congruent. They want us to find MN, and that's this, the measure of MN. So we can do that by setting up a proportion. M and N need to have the same relationship as J, L, and LN. They have to be 75 to 1, right? So I'm going to write that ratio. It's going to be 75 to 1 equals, okay, let's review which one's bigger, JK or MN? JK or MN? JK. So the bigger number needs to go on top. So 10 is the bigger number here because the 75 is bigger, right? And I'll write that big over small. And so this is my unknown, the X, MN. Now that I've set up my proportion, since the ratios should match, I'm going to just cross multiply. So X times 75 is 75X. 1 times 10 is 10. I divide by 75, I divide by 75, and I get x equals, let's take my calculator, a really small number. Equals 0.13 with a line above it. Any questions over that? We're all good? Okay, we're gonna do another one similar to that. Okay, Avery puts up a radio antenna tower in his yard. Ella tells him that the city has a law limiting towers to 50 feet in height. How can Avery use the length of the shadow and the shadow of the tower to show that this tower is within the limit without directly measuring it? Well, it's really nice because they've given us similar triangles, right? They've given me a similar triangle here with Avery as the triangle, and they've given me the similar triangle with the tower. You can tell they're similar because it has a congruent angle to this and this. And then right angles are always congruent. So the two triangles are similar through angle. Triangle ACB is similar to triangle RTS by angle similarity. So what would be my scale factor? Very good. My scale factor is going to be 5 and 40. Doesn't matter where you put it because they didn't tell us which one was the image and the pre-image. So 5 over 40. So 1 over 8. Okay. Or 8 over 1, however you want to write it, right? That's either one. This is 1/8 of this, or this needs to be multiplied by 8 to get this. Does that make sense? Okay. So if this part is 6, what would this length be? If he's 6 feet, how big would this be? It's 8 times bigger, right? Okay, very good. So ST is going to equal 6 times 8, which would be 48 feet in this case. So does that fit within the city's law?
Yes.
Yes. Yes. How can Avery use the length of his shadow and the shadow of the tower to show that his tower is within the limits without directly measuring it? Yes. By using similar triangles. And the scale factor. Any questions over that? Okay,